Okay. So you have a good rest just now. Okay, my voice is clear. The slide is okay.
Yes, Prof.
All right. Thank you. I think we can continue. All right. So, all right. We stopped just now at experimental design. So I think by today we can just complete experimental design and graphical abstract. Okay. Okay. When we're talking about experimental design, of course, things that come to your mind will be um, methodology, right? So methodology section. Okay, let me look at all. Okay, so when you have done all the literatures, I mean, you have gone through what are the parameters, methods. Methods means it can be preparation method, it can be characterization methods. You so before writing this experimental design, there are a few processes that you have to do. One, of course, the literature review just now. You have made comparison, you have done some interviews, you have read reports or whatsoever that, and then you compute everything, and then you can conclude that you want to adopt certain methods or certain preparations or certain characterization that you think is suitable for your research project. Okay, so that has to be done, means that a proper literature first. Okay, apart from proper literature, you can always do interviews. For example, you can talk to your colleagues who have done the process, or you can talk to the seniors in the lab, or you can talk to other scientists. Okay, it's not just literature. You can always do some homework by talking, by discussion with other scientists or other colleagues that have some experience in doing that. Okay, so but before writing this down, so you have to do that. Okay, and another one is you have to uh, think about the factors just now. The three factors. One is, of course, the time that you have. Okay. The second one is the cost, the money that you have. And the third one is the technical instruments that you have in the lab or you can access to. Okay. It does not mean that everything must be in your lab, but you know where to access. For example, you can access a complicated instruments in another university or in another research institution, but you know you can access, you can pay them for services or whatsoever, so you can do that. You have to consider that before writing a proper experimental design. Okay, so these three things, um, um, yeah, I usually say this when you write, especially when you are doing PhDs. Yes, PhD, one PhD, and if you are doing master, okay, master is very short term, so PhD probably long term. You are talking about planning of your life. So when you do this experimental design, you are doing a planning with your life as well because it's about timing. So as I mentioned, this is related to objective. So since you have designed a proper scope of objective, depending on your whether you are doing a short dissertation or you are doing a PhD, okay, this one has to be properly discussed with your supervisor. your supervisor should approve the scope first because he or she understood the scope well. They should understood that whether if you are doing PhD, this is the scope. Whether you are doing a short dissertation, this is your scope. So let's say you are doing a short dissertation. So you choose only one objective because of the time limitations and all that. Okay. So now you have done the literature and you are moving to writing your experimental design. Okay. So I'm giving an example of the first one is on the nano transducer. Okay. The one that I have written down here is for the purpose of grant application. So as you can see in the method section, okay, or the experimental design is very general. This is purposely done because when we, researchers especially, when we apply for a research grant, it's difficult to make it very detailed. One is we want to keep some secret, okay? There is, of course, some secret to the steps. And then when the grant proposal is sent to someone else, we don't want people to like take the secret or whatsoever from us. So we have to write it in a general way. But for your proposal, whether it's PhD or for your master dissertation, I suggest that you write it in detail. Okay. So why you write in detail? Because this is what you're going to refer back. Okay. So usually what happened is most of the postgrad students, including me when I did my PhD during my time, is we write this proposal. It's not in a serious manner. We write it just for the purpose of, I mean, you need to submit to your supervisor, you need to submit to someone to get the marks. That's it. But it is very important if you can write it in a way that you are planning for your life for the next 3 or 4 years if you're doing PhD. If you're doing a short dissertation, you are writing it for the what one semester program or one semester planning because this will help you to complete it on time. Okay, so before writing it down, you have to consider certain factors. One, because you know you are doing, if you are doing chemistry related work in the lab, you have to look at what are the chemicals, what are the materials available. Or if you need to secure, means that you need to buy or you need to get from someone else the chemicals, the material, you have to make sure that you're going to get it in what, 1 month time, 2 months time, or 3 months. Because if you like plan to have a new material and you need to buy it, you, especially in Malaysia, you have to secure or you have to know the process of purchasing takes sometimes because it involves shipping and all that. So you need to take that into consideration, especially when you are writing the timeline of the experimental design. Because experimental design, as I mentioned just in the list, this is also related to Gantt chart. Okay. So this is a planning. Okay, it's not just you already knew what method, what material, what instruments that you want to use. You also need to know the time planning, how to get, where to get, how to buy, whether you can get it on time. So that is on material. And another big issues is, let's say, here I put characterization, right? Characterization means that because you are a chemistry student and you are a science student, you are familiar with the usage of FTIR, XRD, TGA, and other instrumental as well. So this is also crucial because you need to check whether those instruments are available and working. If you know that you can access those instruments outside your facility, regardless in UPM or whatever outside facilities, and you know it's going to work, it's going to give you results within the time frame that you have planned, then it's fine. Okay? Because this should be in our in our planning. Once it is written in the writing form, I mean, it's fine. I mean, people will endorse, but the timing will affect your life. You want to uh, finish on time. So you have to properly plan this experimental design based on time that you have, material that you have, instrumentation that you can access, uh, as well as the money that you have that you can use. Okay, so those are things has to be planned apart from literature just now, and then these problems has to be thought carefully before you write your experimental section or experimental design. Okay, and the fourth one, which is very important in experimental design, is the right characterization. Okay, let's say my question, because this is the easiest. If you are doing drug discovery, let's say, what are the types of characterization that you need to do? Anyone can suggest. Drug discovery in Malaysia means that you do natural product, means you want to study the active component of certain leaves, certain herbs. So what are the characterization that is commonly being used to study? Anyone? Anyone?
The chemical composition, Prof?
Okay, what do you mean by technical composition? What machines do you
No,
use?
the chemical composition, I mean.
Okay, what machine do you use?
Um, Maybe chromatography. I don't know how it's
Yes.
done.
Okay.
Okay.
All right. Okay. So imagine now we are working on certain leaf, okay, in Malaysia because we have a lot of these resources. So it's good to work on it. Okay, so we extract. Okay, now one is you have to think about a proper extraction process, right? Okay, if you're doing this, you have many options of not I'm not sure when I'm talking many, how many is it, because I'm not a natural product chemist. So you have a few options of extraction of the active components. You might be using polar solvent, you might be using non-polar solvent, or you might be using a mixture of those polar solvents. Of course, from your readings, you have sort of a few strategies. You know, if you want certain active compound and that compound is polar or slightly polar or is non-polar, you know the strategy to take it out from the leaves. You know what kind of solvent that you are going to use. Okay, that's one point. Means that you have to check whether the solvent is available, easy to get, or whatnot. Okay, and one. And then let's say for the second part, you want to make the extraction green. You don't want to use a lot of hexane. You want to make it green extraction. So you read on the green extraction, you strategize on the green extraction. But of course, when we're talking about extraction, we want the extraction to have a high yield. We want to have a uh, uh, a high product from the extraction process. We don't want to have like 1% yield, 2% yield. We want it to be 90% pure yield, for example. So you have to strategize in your experimental design. Write it down in your experimental design based on your reading just now, and also accessibility to the materials, to the solvent, to whatsoever glassware or technical parts that you need to do the lab with must be accessible. Okay. And then just now, Sajita mentioned about characterization, because we are talking about to identify the chemicals, chemical compound in that active component. Okay, the best, of course, we can use LCMS or GCMS. Depends on how volatile your sample is. If your sample is volatile, then GCMS is fine. But if it is not, then LCMS is a must, and is not really accessible everywhere. It's expensive. You have to know whether your compound is enough by using GCMS or your compound requires LCMS. That one from your reading as well. Of course, a discussion with your supervisor. Okay. So those are the things that you have to know. Okay. So let's say you have done this analysis, and then you do extraction, and then you run for whatever characterization that you think appropriate. So in the end, you are in your viva session, means that final session, you presented your results, blah, blah, blah. And then somebody said, your characterization is not correct. Okay. You should not use GCMS. You should use LCMS due to certain characteristic of your chemical compound. So this is what we don't want to happen to you. In the end, you choose the wrong machines, the wrong instruments to analyze whatever that you plan to analyze. So you must make sure the instrumentation, the characterization that you suggest in your experimental design is the standard way of doing things. There are standard ways of doing things. There are standard ways, for example, to study biofuel. There are standard ways to characterize nanomaterials. There are standard ways to do drug discovery process. Those are published standard ways. Okay. Standard means it's a very general things that we do. For example, if you are developing nanomaterial, you have to prove that it is nano. So how do you prove it that the material is nano? You have to do morphological study like FISAM, high resolution, HRTM. Okay, that prove the size is nano. So if you do nanomaterial, you cannot claim it is nano unless you do these two. So, and you cannot also give reasons in the end that I cannot do FISAM or HRTM because I don't have access. So this is not acceptable. So that's why when you plan experimental design, you have to consider limitations. Okay, if you cannot do that, then you have to change the title. You have to find another problem that you want to solve. Okay, you have to make sure that it is within your reach, the instruments, the facilities, or whatsoever. So this is very important for you to consider when writing experimental design. Okay. So question before I proceed with another biggest factor in experimental design. Any questions?
So, Prof, so can
Yeah.
I conclude that to determine the design that I want to proceed um for my experiment is based on my literature review, which means I compare and contrast on whatever has been done, and then I come up with my design. Is that works that way?
Yeah, it looks that way. And you also have to consider the one that I have mentioned just now, your accessibility to that facilities. Do you have it? Okay.
Yeah, understood.
Yeah, very
Okay.
important because you are planning about your life in another, or if it is PhD, another 3 years. So you don't want to like what we call as sitting duck there doing nothing. uh, where the time is moving, so we don't want that. Okay, I hope you can get this. It's because it is a very important factor that people don't see in your write-up. People don't see. People only know, okay, you have come up with the design, the experiments that you wish to do. But the process of coming out with that design, the human factor, the accessibility, the cost factor, times, they're all human being factor. You have to consider that. Okay, one final part that I think very important, this is personally from my experience, is for you to predict what do I call? Um, I have it in one of my slide, but it's not in this slide. Is you to think about the possible problems that going to happen and what are your contingency. Okay, so in working, okay, in life as well, you should have contingencies. Okay, what if this you have like suggest this chemical A, this solvent A, whatsoever. What happen if it doesn't work? Do you have contingency? Okay, if you do not have, then in the last minute you're gonna have to order some chemicals. It takes some time. So you have to work with contingency. Means that if you are working with certain solvent, you also are working with different solvent that you already have access to. You already know, you already ordered or whatsoever. Okay, it's very important to understand that you need to have contingencies. You of course don't want problem to happen, but it happens. Because it's not always a straight line. It's always deviations. It's not always you get a good results. You will of course observe unsuccessful um, works. Again, you keep trying for the whole semesters, and you don't get it. So that will happen eventually to some of us. So I don't know. For me, based on my experience, you should have contingencies. What you call plan A, plan B. What happen if you don't have this? You plan, but probably it is not written there in experimental design. But if you don't write it, your supervisor will not be aware of your contingency. So it should be written there. So if it is written there, then the supervisor will endorse. Okay, I understand that we will buy these things, these materials, even though you're not sure you're going to use it, but you have this plan A, plan B, plan C. Okay? I hope you understand that because that's very important. But for master dissertation, I believe it is not going to be to that, you know, up to that detail. But if you're doing PhD, you have to think about it. If you really want to finish like 3 years, you have your fellowship, your scholarship until 3 years, and you need to finish it. That should be in your planning. As I always tell students that writing experimental design is writing your life plan for the next 3 years. Okay, because you're going to be in the lab. Okay, if you don't plan and then it doesn't work, then you have to spend more times in the lab, for example. So you don't want that to happen. Okay, so things happens and experiments just not always successful. Yeah, you have to consider contingencies. Okay, I think that is experimental design. And of course, in writing part, you have to use future tense because it's future, it's not yet done. Okay, you can see that I'm using will be here, can be, right? So you have to use future tense. You don't write it in past tense, okay, because it's not yet happened. Okay, questions before we move on to the last part?
Prof, in actual, if our experimental design is approved by the supervisor, so can we start immediately the experiment to make sure that if let's say there is a hiccup, then we have time to do our contingency plan?
Of course, actually for as I mentioned, for small scale project, usually that's why my advice is for you to always discuss with your supervisor so that your supervisor understand your situation. You only have half a semester to complete your lab whatsoever. So whenever you have problems, you have to talk to your supervisor, talk about it. Okay, what should I do? Okay, let's sleep 1 minute. Okay, let's say the supervisor said, let's sleep 1 minute for one night or for a week, it's fine. But if you don't tell her or him, and then in the end, you talk about the problem, then, you know, as a human being, it's difficult because it's towards the end. And I agree, if you like have done the experimental design, it's not supposed to be like a complete one, a perfect one. No worry, because you can change along the line, you can change along the work, along the project, you can still change. But at least you have some ideas what to do. Okay, before coming into the lab. That's why we need experimental design. Okay, so I think we move on to the last part, which is very important as well, is graphical abstract. Okay. Graphical abstract is like executive summary represented in a form of graphics. Okay, of course, in graphical abstract, we don't have like the introduction part, telling that the statistic whatsoever. But for us, especially those who work, who have experience in science or whatever, if you look at the graphical abstract, you can evaluate whether the science is solid and is going to be working. Okay, like myself, if I look at this graphical abstract submitted by one of the students, and I know how it's going to work. Okay, I know from here that he or she is going to use a graphite electrode. And I know that the student is going to use a certain type of polymer. And that polymer will be embedded on this electrode. So I can scientifically explain the process, or I understand the process. And to justify to like characterize the embedded polymer, there are certain optimization that will be carried out. These are called electrochemical parameters. They will do cycles, scan rate, whatever that you want to put here. And then certain characterization in terms of morphology. I understand that he or she will do this SAM, CV. CV is electrochemical method, EIS as well is electrochemical methods. So from this small section of the graphical abstract, I can understand the whole idea of what the students wish to do. Okay, and then additionally, because he or she is going to use DNA, so I know that the DNA will be on top of the polymer. And then how the hybrid, okay, I'm not going to talk about the DNA or whatever. So how the process will be before obtaining the signal is by using this material called methylene blue. Okay, so from all this, if you understand the process, is very easy. Reading is one part. I will read of course, the executive summary, and at the same time, I'll be looking at the graphical abstract. So the skill of translating your executive summary to in a form of graphical abstract is very, very important. By hook or by crook, you have to do this. Because in future, if you are to publish in journals, let's say in future, they now requires graphical abstract. Means that abstract in the form of graphics. So these are skills, because graphic requires you to do graphics. So if you have a skill in doing graphic, then you are blessed. But if you don't know how to even draw something, do some graphical abstract, it's very, difficult. Okay. So this is something that you need to do together with your proposal, is to have a one slide of graphical abstract. Please try your best to do this. Okay, question on graphical abstract. It does not has to be a very nice drawing. Okay.
Besides, we draw ourselves. Can we take it from other source?
Yeah, sure. But you can like cut, but it's a mixing process. So sometimes I do admit that I don't have the skills. I did some before, like the instruments part, I copy and put it here, so it looks nice. But you do the mixing. It's not straight away everything that you copy and then paste it in your slide, but at least part of it. For example, these DNA parts, you can, take from the Google, and then because it's a general DNA structure, so you just put it on top of your electrode here, for example. Okay, so you can do that, but not the whole thing. Okay, if it is the whole thing, then it's someone else's idea. Okay, you're talking about abstract, your abstract. You're talking about your executive summary. Okay.
Prof,
Yeah.
Prof, for graphical abstract, I think this is easy to illustrate if we are doing something like wet chemistry for the master dissertation. How
Yeah.
about like something like survey based? Do we still have to have like graphical abstract, and how do we do that?
Okay, I understand that question. Okay, if it is survey based, it can be like flow charts. Okay, can be like flow charts. Okay, types of samples that you want to do. For example, if it is school based, you want to study the chemistry related school based, and on titration, for example. So what kind of samples you want? What types of schools? Boarding schools, public school, daily schools. Okay, for example. So you have to put it in the graphical abstract as well. And then how many you put it here, and then you have the flow of the question given to them before you have the animation, for example. And then so the process is there for people to understand. So it's like a flow chart, right? You don't have to draw all this. Okay. Yeah,
Okay.
all right. Yeah. Okay, so let's go to the conclusion. I don't have the conclusion here, but then next week we are going to do powerful presentation. It's not saying that I have a powerful skill of presentation, but the usage of the word powerful at least differentiate from the normal presentation. Okay, so in proposal, so there are two that we don't really discuss, which is very technical, so you don't have to worry about, which is the Gantt chart. Okay, you just find any Gantt chart from the Google. Okay, you can just use this any template of Gantt chart, as long as it is nice to look at, easy to understand. That's it. Okay. So and I don't have that the example. I should show you the Gantt chart. Okay, so we have covered everything. You don't need to conclude. Like if you're doing for your final year project, usually at the end you explain about the expected results, right? Actually, you don't need to, because it is understood your expected results. It should be the objective that you want to achieve. So you don't have to write it down. Okay. But the risk management, especially if you are proposing for money, those grant providers, stakeholders would like to see the risk management. Okay, and you should be you should be transparent on this, whether you're gonna have time risk, cost risk, or technical risk. Okay. All right. So I think this is the last part on the written proposal. Before we move on to the next one, not today. What I'm going to do is to divide you into groups because we are going to do some activities next week. Okay, just a glimpse on the powerful presentation. There's these tools that I used to do the practice with, and ABC tools. You can search for it before next week. So today, what I'm going to do, we have around 15 of us, okay? All right. And then who with me on Monday, I'm going to open a breakout room, and then you will be automatically sent to the room, and then that will be your group members, okay? So I will do it now, okay? Breakout rooms. So you will have, I think, 3 per rooms. Okay, so 5. 1, 2, 3, 4. Okay, so I hope everybody can start to join. Okay, I'll see. All right. So I see room 1 has already Ahmad, Valerie, and Shalini. Room 2, we have Amira, Navitra, and Farah. Room 3, we have Lily, Sajita, and Zawa. And then room 4, we have Atika, Hidayah, and Xiao. And room 5, we have Asma, Hafiza, Izdi, and Nabila. Everybody is good? So get to know your member, at least their names. Okay. So I'm going to screenshot this. Okay. So I think I can close all rooms, so everybody will be in the main room for further instruction.